Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8, Unit 7, Lesson 13. Our first problem here, the warm-up is find the value of each expression mentally, which means in your head, can you think of what the value of these are? No calculators. 123 times 10,000 is 1,230,000. 3.4 times 1,000 is 3,400. 0.6 times 100 is 60. 7.3 times 0.01 is 0.073. Quick refresher on place value, multiplying by powers of 10. Next problem says the science of scientific notation. The table shows the speed of light or electricity through different materials. This is a table we've seen before. Now what we are supposed to do is circle the speeds that are written in scientific notation. Scientific notation means we are multiplying it by a power of 10, and we have one digit in front of the decimal place. So water was already written in scientific notation. 2.25 times 10 to the power of 8. No power of 10. Ooh, diamond has a power of 10, however, we don't have one digit in front of the decimal place. Ice, 2.3 times 10 to the power of 8, times the power of 10, single digit in front of the decimal place. Ice is written in scientific notation. Olive oil, 0.2 times 10 to the 9. Again, we do not have one digit in front of the decimal place. So now we need to write the ones that are not in scientific notation. Space will be 3 times 10 to the power of how many spots did we move the decimal place? 3, 6, 7, 8. 3 times 10 to the power of 8. Water's done. Next we have copper. $280 million. One digit in front of the decimal place, 2.8. Now you'll notice the decimal point goes in the same place it was for space. 3, 6, 7, 8. 2. Whoops. 2.8 times 10 to the power of 8. Diamond is already to a power, or times a power of 10. However, we don't have one digit in front of the decimal place. So for diamond, we want one digit in front of the decimal place, 1.24. Now, this is already times 10 to the power of 6. We want to move the decimal point from where it currently is 2 more spots. 2 more spots than 6 is 8. Our last one of these is olive oil. For olive oil, this looks kind of like scientific notation. However, we again don't have 1 digit in front of the decimal place. We want our decimal point to be here. Now this time we're going in the opposite direction. So this will be 2, because we want 1 digit in front of the decimal point. We could do 2 or 2.0 times 10 to the power of 1 less than that, because we went the other direction. 1 less than 9 is 8. Olive oil 2 times 10 to the power of 8. Our next question here is the Are You Ready for More? We would have done a matching card sort. That doesn't translate well to a remote learning group project, so I'm going right on to this. What is 9 times 10 to the negative 1 plus 9 times 10 to the negative 2? Express your answer as a decimal and a fraction. So we have to think about what these numbers are. 9 times 10 to the negative 1 is 0.9 as a decimal. 9 times 10 to the negative 2 is 0.09. Express your answer as a fraction. 10 to the negative 1 is 1 over 10, which is 1/10. 9 times 1/10 is 9/10. 9 times 10 to the negative 2 is 9/100ths. If we add those together, we get 0.99. If we add those together, we get 9/10 plus 9/100ths. We would have to give those a common denominator. The common denominator would be 100. Multiply that by 10, multiply that by 10. 99/100ths. Okay. Now, our next one here, what is 9 times 10 to the negative 1 plus 9 times 10 to the negative 2 plus 9 times 10 to the negative 3 plus 9 times 10 to the negative 4? As a decimal, that is going to be 0.9 plus 0.09 plus 0.009 plus 0.0009, which is equal to 0.9999. As a fraction, it will be 9/10 plus 9/100ths plus 9/1000ths plus 9/10,000ths, which is equal to 9,999 10,000ths. So our answers should match. One is written as a decimal, one is written as a fraction. The answers to the 2 previous questions should have been close to 1. 99/100ths is close to 1. 9,999 10,000ths, even closer to 1. What power of 10 would you have to go up to if you wanted to have your answer be so close to 1 that it was off by only 1 millionth? Well, if we think this one here was off by 1/10,000th, which is here, let me erase that. 1/10,000th was here, two more spots. This went up to 10 to the negative 4, so we would have to go up to 10 to the negative 6, which, if we look at this has 6 zeros. What power of 10 would you have to go up to if you wanted your answer to be so close to 1 that it was only 1/100000th off? Well, 3 extra zeros, we would have to add 3 more to this. We would have to have up to 10 to the power of negative 9, now that there are 9 zeros. Can you keep adding numbers in this pattern to get as close to 1 as you want? If we kept adding powers, we would just have to continue adding to the absolute value of this. This could be 10 to the power of negative 1,000. This could be 10 to the power of negative 1,000,000. That would keep getting us closer and closer. Now we have a little bit of a challenge problem. This was always one of my favorite riddles. This is Zeno's paradox. Imagine a number line that goes from your current position, labeled at 0, to the door of the room you are in, labeled as 1. In order to get to the door, you will have to pass the point 0.9, 0.99, 0.999, 9/10ths, 99 100ths, 999 thousandths. The Greek philosopher Zeno argued that you will never be able to go through the door because you will first have to pass through an infinite number of points. What do you think? How would you reply to Zeno? So, if you are continuously getting closer and closer, think back on this. Could we ever reach the point where we have actually made it all the way to 1? So that's your challenge question, deep thought. Let me know what you think. This has been another Mr. Boskin Helps You